All right, trapezoids, trapezoids, trapezoids. Trapezoids are an interesting shape because if you can take a look here, I have two different pictures that are on my screen, and they are both trapezoids. Trapezoid is one of the fewer shapes, it's kind of like a triangle, where there can be different varieties, but they all are considered still trapezoids. If you look at the first one over here on the left, this trapezoid has not just one, but it has two 90-degree angles that are in it. Where if you look at the other trapezoid over here on the right-hand side, this one's formulated by two angles that are acute angles that we talk about, and it also has two angles up here in the corners that are obtuse. Either way, it's a four-sided figure. You know the angles inside have to add up to be 360. Now, like I said, they can have different looks like we can see. They're clearly, they look a little bit different, but you figure out how you find certain measurements the same way as you do any other shape. When you find a perimeter, you just simply add up all the sides that the shape has. Technically, for all intents and purposes right now, we could not find the perimeter of the trapezoid on the left-hand side until we were able to calculate the missing slanted side. But on the right-hand side, I could calculate the perimeter of that guy. I can go around here and I can add up all its pieces, just going simply around here. 12 and 6 make 18, and 5 and 5 make 10. So that's going to be 28 inches as a perimeter. The other thing that you're going to be able to calculate is you're going to be able to calculate area. To calculate your area, you need to make sure that you understand what these measurements are. You need to know what this H stands for. You need to know what the B1 and the B2 stand for. To do the area of a trapezoid, it's actually quite a simple process, and I always explain it this way. What you're essentially going to do is you're going to be multiplying three values together. That's it, three values together. The first of the values you need to find right off the bat. That's the B1 and the B2. So let's look at the example first on the left-hand side. The B1 and the B2 are always represented as the two sides of the trapezoid that are parallel. Now, this is the most important part. Let me say this again. The two sides of a trapezoid that are parallel are the B1 and the B2. It doesn't matter which one you call B1, and it doesn't matter which one you call B2. But when you identify the two parallel sides, you want to take them and add them up, because that right there, that's the key piece. Sometimes a trapezoid can be flipped. You can rotate it 90 degrees, because the biggest mistake students tend to make is they say, oh, you're talking about the top and the bottom. Well, in this example, I am. But if I take that guy and rotate it 90 degrees, now the 4 and the 9 are on the sides left and right. They're still the parallel sides, and they still represent B1 and B2, depending on the perspective of how you're looking at them. Now, to utilize this formula, what this formula is simply saying is you're going to take a half, which is 0.5, and then you're going to multiply it by the H, which stands for the height. We'll explain that in just a second. And then last but not least, you're going to be multiplying it by this value right here that we just got. In our case, it's going to be 13. The H, the next thing that I want to explain, the H is the distance that is the parallel sides are apart. So H in this first example is going to be 6. The height of a trapezoid always has to form a 90-degree angle with the bases. Again, let me say that again. The height of a trapezoid always has to form a 90-degree angle with the bases. If we want to get into mathematical lingo, the height and the base of a trapezoid are always perpendicular to one another. They formulate this 90-degree angle. Never will the height be a slanted variant. It'll always be perpendicular with either of the bases. So now what I know is, now I know my H value is going to be 6. So when I apply my math formula, I take 1/2 here, then I multiply it by the height of the trapezoid, which is 6, and then last but not least, I'm going to be multiplying it by the B1, the B2 added together. So then when I go through and I do my math, half of 6 is 3, and 3 times 13 gives you 39 units squared. And that was inches, so inches squared. So 39 was the area of that first trapezoid that we were looking at. Now, if I look at the trapezoid over here to the right, the trapezoid over here to the right is done basically the same way. Got the B1 and the B2. So identify the sides that are parallel. That would be 6 and 12. So these guys are going to come up to be 18. But notice something else. These 5s right here, these 5s are slanted. That means they are not the heights. They are not the height. The height The H of this trapezoid is actually inside here. We refer to this as dropping a perpendicular. We actually went, that's the distance. The distance from parallel line to parallel line in this problem comes out to be 4. So now 4 is represented as my H. So when I go through and I apply my math formula, I take half of 4, which we all know is 2, and then I multiply that by 18, and 2 times 18 is going to give me 36. And again, this is a situation where it's inches squared or units squared, which comes out to be my area of the trapezoid. And that, ladies and gentlemen, is how you find the area of each and every single trapezoid. I hope you found this both helpful and informative.